if we want to solve this three variable, three equation system of equations, again what we're looking for is x, y, z. That's what we're looking for. And our job, our way of doing that is to first of all make an equation where we cancel one of the variables out. And then we make a second equation where we cancel the same variable out again, but using two different equations. So when I look at these coefficients, I have 4, 3, 1, negative 2, 3, negative 5, 5, 8, negative 3. I look at those and go, okay, what's the easiest numbers to cancel? What can I multiply by the smallest numbers to get rid of a letter? And what I notice is probably x is easiest to get rid of. Because x has this, and all you do if you want to say cancel 2 and 3 is multiply by negative 3. If you want to cancel 1, you multiply by negative 4. I see that as probably the easiest. There are other options, but that's probably the easiest. So basically, what we're going to do is, in order to do this, first of all, we're going to take that third equation, and I'm going to take it, and I'm going to multiply that third equation. Actually, let's put the let's do the first equation too. The first equation is 4x minus 2y plus 5z equals 6. Now, what do you want in order to cancel this x with this 4x? What are you going to multiply the top by? Negative 4. In order to cancel the x's, you have to multiply everything by negative 4. So that would end up with, our third equation would now be, third equation becomes a negative 4x, and negative 4 times negative 5 is positive 20, and a positive 12z, and that would give us negative 20. So what we do then is we add down, and these two cancel. This gives us 18y, this gives us 17z, and this gives us negative 14. That we call our fourth equation. Okay. Now we got to choose, we choose the first and third that time. I would probably choose the third and the second and get rid of x again. Because what are you going to multiply this by? Hopefully you notice you're going to multiply this by negative 3. So I'm going to take the third equation, and I'm going to do it in my head. I'm going to multiply this third equation by negative 3. So that would be negative 3x. Multiply this by negative 3, I get positive 15y. Negative 3 times negative 3 is positive 9z. And this would become negative 15. And then the second equation we rewrite, because we're canceling with the second equation. Alright, that cancels. Again, you want to get rid of the same variable both times. It's all about the same variable. And we have to use different equations. You can't use the first and third and the first and third again. You have to use a group of two different equations. Anyways, you get 18y, here you get 17z, and here you get negative 11. And we call this our fifth equation. Now, what we're going to do here is we now want to find y or z using elimination with these two equations. So, it doesn't matter which one we try to get rid of. We get rid of whatever's easiest. Now, do you notice the 18 and 17 match up? So we probably want to multiply one of these by negative 1.
Correct.
So what I'm going to do is I'm just going to multiply this one by negative 1. Is that okay? That our fourth equation will now become negative 18y minus 17z equals positive 14. And I'm going to bring this guy down. There's our fifth equation. We brought him down. And now we're going to cancel. Ooh, what do you notice?
Yeah, they're all going to cancel.
Don't both those cancel? And this becomes 3.
That's what
That is a no solution. That is a false statement. So my answer is no solution. Now, if that ended up being 0 equals 0, it would be infinite solutions. But since everything dropped out, you get a no solution. This is just like normal systems. If this happens along the way, it's a no solution. Be very happy. You're done. Got it? If everything drops out, it's a no solution at some point. It saves you time. Now, if we could have solved for y or z, you find y or z and keep working on it. But this one is just simply no solution.